Hello everyone, welcome to Maktab. This is our physics video series on motion, and this is lecture 5. In this lecture we will learn about graphical representation of uniform and non-uniform motion. In the previous lectures, in the previous videos, we have learned about uniform and non-uniform motion. If you have not seen that video, you can see the video. Everything will be cleared about uniform and non-uniform motion. So let's start. Basically, what is the meaning of graphical representation of motion? It is simply we have to show the distance which is traveled by any body in some time in the graphical form. We have to show the distance measured or distance covered by a body in time using a graph. So you can see here there are four types of graphs. This is the first one, the second one, and the third one, and this one is the fourth one. All of these graphs are showing the distance covered by a moving body in time. The axis, this axis on which the distance is measured, this is known as the y-axis, and the axis on which the time is there, this is known as the x-axis. I hope you have learned about the axes in maths. This is the x-axis, this is the y-axis. So keep it in mind that always you have to take time on the x-axis and you have to take distance on the y-axis. And when you will draw the graph, this will give you the distance time graph for different type of motions. So let us see the first type of motion. The first one is uniform motion. So we will see how we can draw a graph for uniform speed or uniform motion. So basically, what is uniform speed? Uniform speed means that a body is moving and it is traveling and it covers equal distance in equal interval of time. So when a body is moving and it is covering equal distance in equal interval of time. So that is known as your uniform speed. Then we can call that the body is moving with a uniform speed. So if you have to draw the graph for a body which is moving with a uniform speed, the graph is always a straight line. It will be a straight line. So keep it in mind that for uniform speed, the graph is always a straight line. And this is a graph between distance and time. Now here, the slope of speed time graph indicates the speed of the object. Now suppose that there are two bodies. There is body 1 which is moving with a different speed, and there is body B which is moving with a different speed, and both of them are in uniform motion or moving with uniform speed. So let us say if I draw a graph for body A, and this is something like this for body A. Similarly, if we draw a graph for B, and let's say it is coming like this, B. Now how we will come to know that which body A or body B, which body is moving with fast speed, right? So there is very simple calculation for this. You have to see the slope. You have to see the slope of the graph. Slope of the graph. The more the slope is, the higher the speed of that object. So what do you mean by slope? You can check the angle from time axis. So let's say this is the angle for B and this is the angle for A. Let's say this angle is 1 and this angle is 2. So here you can see that angle 2 is greater than angle 1, right? So it means slope of A, it is greater than slope of B, right? If the angle of any graph is greater, that means its slope is greater. So here the slope of car A is greater than the slope of car B. So we can say that speed of A is greater than B, or you can say speed of B. So is it clear? So in this way, if there are three slopes given to you, if there are three different cars or three different moving bodies and their graph is shown to you and question is asked which one is moving with a greater speed and which one is moving with a slowest speed. So what you have to check is you have to check the slope of the graph. The slope will give you the speed. More the slope, more the speed, and lesser the slope, lesser will be the speed. And to calculate the slope, you just have to check the angle. Which graph is having the most angle, maximum angle, and which graph is having the least angle. So in this case, the body A was having the maximum angle and body B was having the minimum angle. Therefore, A is moving with fast speed and B is moving with a slower speed. Now let's see graphical representation for other type of speeds. So it is for non-uniform speed. So what is non-uniform speed? If you don't know about this, you can check the previous video. So basically what is non-uniform speed? When an object covers equal distance in unequal interval of time, or you can say vice versa. If an object is covering unequal distance in equal interval of time, right? So this is the meaning of non-uniform speed and how we can draw the graph for non-uniform speed. So the graph will be like this. You will get a curve, right? You will get a curve for non-uniform speed. And when a body covers unequal distance in equal interval of time, then we say that the distance traveled by the body is not directly proportional to time, right? In the previous type of motion, in uniform speed, in uniform motion, you can say, or speed, in this type of motion, the distance was changing linearly with time, right? There was equal change in distance when the time interval was changing. So in such case, you can say that the distance is directly proportional to time. And for this, we can use a mathematical expression that is d is directly proportional to t. Here, this sign is for directly proportional. So it means that equal distance is covered in equal interval of time. For example, if a car is moving, so at 2 minutes, it was moving with some speed and it has covered, let's say, 100-meter distance. So for next 2 minutes, it means after 4 minutes, it will cover 200-meter. And after next 2 minutes, that is after 6 minutes, it will cover 300-meter. And the next 2 minutes, that is after 8 minutes, it will cover 400-meter. So here you can see that the car after every 2 minutes, the car is covering distance of 100 meters, right? So in this, the car is covering equal distance in equal interval of time. It takes 2 minutes to cover 100 meters. For every 100 meter, it takes 2 minutes. So such type of speed, in this type of speed, we can say that the distance or the time is directly proportional to distance, or distance is directly proportional to time. But in non-uniform motion, we say that distance, it is not directly proportional to time because the car is taking different distances in different time and the graph will be a slope. Now next, this is very interesting. This is a distance time graph for a stationary object. Stationary means if object is at rest. So how you will get the graph of such objects? So it will be a straight line which will be parallel to the time axis. You will get a straight line which is parallel to the time axis. Here you can see that the time is changing. See the graph, the time is changing. Let's say this, there is some time, uh, just a second. So at this time, the distance was, let's say this is x, the distance is x. Similarly, next time the distance is same x. For another time interval, the distance is again same, it is x, and another time interval, and for another time interval, the distance is same. So you can say the distance is same for the time intervals, right? So it means the object is not moving at all. The speed of the object is zero because it is not covering any distance. The time is moving, but it is not covering any distance with the passage of the time. So we say that the speed of this object is zero, and this is a stationary object. So for every stationary object, you will get a line which is parallel to the time axis. So in this video, we have learned about graphical representation of various different type of motions. For uniform motion, you will get a straight line graph, and the slope of this line will give you the speed. The more the slope, the greater will be the speed. For a non-uniform motion, you will get a slope, you will get a curved graph, right? And for the objects which are not in motion, which are at rest, you will get a straight line graph, and which is parallel to the time axis. So in the next lecture, I will tell you how to draw these graphs. We will learn about the drawing of distance time graph. We will see some numerical problems on based on these. Thank you for watching. Have a nice day. If you like our lecture, please share this with your friends and subscribe the channel. Thank you.